Good afternoon, my YouTube viewers. Crystal here. I just wanted to make another video for you, and what I'm doing in this video is I'm comparing logistic regression in sklearn with logistic regression in Statsmodels. I don't spend a lot of time in Statsmodels. I think I like sklearn better because I think it's easier to work with in Statsmodels. But I was just searching the internet, and then I found out that there is a comparison between logistic regression in sklearn and logistic regression in Statsmodels. And I thought, well, I'll try this out, and I'm going to try it out on the Titanic dataset. Thought that would be a good idea. And so here we go. I'm going to do a code review for you, and I'm going to go over this using the Titanic dataset. So the first thing we're going to do is we're going to talk about the problem statement using the Kaggle Titanic dataset. So the sinking of the Titanic is one of the most infamous shipwrecks in history. On April 15, 1912, during her maiden voyage, the widely considered unsinkable RMS Titanic sank after colliding with an iceberg. Unfortunately, there weren't enough lifeboats for everyone on board, resulting in the death of 1,502 out of 2,224 passengers and crew. While there was some element of luck involved in surviving, it seems that some groups of people were more likely to survive than others. In this challenge, we ask you to build a predictive model that answers the question, what sorts of people were more likely to survive, using passenger data, i.e. name, age, gender, socioeconomic class, etc. So the first thing that I did was I opened up a file in Google Colab. Google Colab is a good file to use because it's free and it's online, and a lot of the libraries are already installed on it. And since a lot of the libraries are already installed on it, you don't have to worry about installing libraries and Python on your own computer. So we loaded the libraries. We loaded Pandas, NumPy, Matplotlib, and Seaborn. And then what we're going to do is we're going to load the data sets. So we loaded the data sets from Kaggle, but I downloaded the data sets and then put them on my personal GitHub file. So we've got our train file, and so our train file has all of this information. And it's 891 rows by 12 columns. Then we got some information about the train file. We loaded the test file. We got some information about the test file. And then we loaded the gender file, which was just a file that you could use because the Titanic is like the first competition that you enter. And then so they give you a file to use just to help you, give you a little bit of experience entering competitions. I checked for any null values, and there were null values in 3 columns in the train file and 3 columns in the test file, and those files had to be imputed. And so because I was doing it quickly, I just replaced all of the columns that needed to be imputed with the mode. But I think I would have got a better outcome if I had done it as the numeric columns with median and the categorical columns as mode. I think I would have got a better outcome if I had done that. So I might go back and change that just to see if I'll get a better accuracy. So then what we do is we do a plot of the survived and the died. So you can see that there were more people who died than survived. The died was 0 and the survived was 1. We did another plot on that, just a little bit, doing a group by. So now what we're going to do is we're going to process the data with the ordinal encoder. So we were going to make all of those columns that were categorical into numeric columns. We made a heat map, if you like heat maps. We set up our X and Y values. So Y is train survived, X is train drop, passenger ID survived, name cabin ticket, X test is drop, test drop, passenger ID, name cabin ticket. And then we check the shapes of all of these data frames that we've created. And then what we did was we split the X file up for training and validation, and then we tested the shapes as well. And then we also put everything on a scalar. So X train scalar equals standard scalar fit X train. And then we transformed X train, X val, and X test. So now what we've done is we've counted the values of died and survived on the validation set, and we set up class weights as well, because indefinitely in logistic regression they have class weights. Now what we've done is we've applied PCA, but we're not really using it in this particular section of the program. So what I did was I set PCA equals 7, and that's the number of columns we had, I believe. Just let me double check that. Yeah, that was the number of columns that we had. So if you set your PCA up for the number of columns that you have, then it doesn't work. It nulls it out. So we got PCA set up, but it's nulled out. Okay, so now what we've done is we're doing from sklearn linear model import logistic regression. So we set up our model for logistic regression, and we had a 79% accuracy, which was a lower accuracy that I've gotten using other models. And then we predicted on xval, and we got a 72% accuracy, which is a lower percentage of accuracy that I've gotten in other models. And then we set up our confusion matrix. So if you like looking at confusion matrices and you know how to use them, then you've got a confusion matrix, because it talks about false positives, false negatives, true positives, and true negatives. So if that's what you like to do, then yeah, go ahead and look at the confusion matrix. So then we printed how many people perished and how many people survived. And so they had 5 more people perished than actually perished. And then what we did was we set up a data frame where we compared the actual values against the predicted values, but we only had 72% accuracy. So then we were going to make a prediction on the X test. And so what I did was I created a file called skSubmission.csv, and that means sklearn. So, and then we submitted our predictions, but we're not going to submit the predictions because the accuracy of logistic regression is not high enough to justify me doing all that work to put it on Kaggle and then submit it. Because what I have to do is I have to go to Kaggle, and then I have to copy and paste all of the columns over. And I don't really want to do that. So I know that I'm not going to have a very good accuracy. I mean, my last accuracy was like 77 or 78. So I'm just going to leave that accuracy there. and just stick with the XVal, the validation set. And now what we're going to do is we're going to put statsmodel logistic regression on the prediction. So we're going to predict on statsmodel logistic regression so we can compare sklearn to logistic regression. No, sorry, sklearn to statsmodels to see which logistic regression works best. And the thing about statsmodels is they call it logic. They don't call it logistic regression. They call it logic. And then I found this quite by accident because I was looking at Stack Overflow, I think. I was looking at a website and somebody asked the question, and she said she was trying to compare logistic regression in sklearn with statsmodels, and I thought, well, I didn't even know they had logistic regression in statsmodels, and so I thought, well, that's a good thing for me to do, is to try to learn how to use logistic regression in statsmodels. So logit equals SM logit y train x train fit. And you can see that this function is written differently from sklearn. So from what I understand and from what I read in literature, statsmodels is written more like R. So statsmodels is a little bit more difficult for somebody who's using Python to use because it's written with this R flavor to it instead of a Python flavor to it. And it's written differently from sklearn. So that's another thing we have to worry about. So they don't give us an accuracy. It just says current function value .46. It says 6 iterations. But you do get to print a summary. And so you can look at the summary and see if you can glean any information from the summary. And the reason why is because Statsmodels is a statistics library. So they're going to have a lot of statistics information in it. And then so what they're doing is they're talking about y hat equals logit.predict xval. So I'm predicting on the validation set. And it said pred equals list map round y hat. And then they make it a float. They don't make it an integer. They make it a float. So in order to get it an integer, which is what I wanted, I said pred equals np array, pred dtype equals np int 64. So that was how I converted this float to an integer, which is what I wanted. And then so now what we do is we check our accuracy. So our accuracy is 76% approximately. And then what we do is we do another confusion matrix. So if you like confusion matrices, there you go, there's your confusion matrix. And then we put it on a counter, and it said 57 perished and 33 survived. So let's go back up to yval and see what it says. It says it said 55 perished and 35 died. So it looked to me like that was closer to the truth than Scikit-learn's logistic regression. So, and we did get a higher accuracy. So we put it on our confusion matrix. So if you like confusion matrices, you can see how many false positives, false negatives, true positives, and true negatives you had. We put it on a counter. We found there were 57 perished and 33 survived, as opposed to actually 55 perished and I believe 35 survived. And then what they do, this is another thing with Statsmodels, you can compare your actual values to your prediction. And so that's what I did. I compared my actual values to the prediction, but I created a data frame where you can compare the actual values to the prediction, which is what I like better. I like looking at a data frame, but if you want to compare it the other way, you can, but I prefer a data frame. So we made predictions as well, and we created a CSV file called smsubmission.csv, and SM means Statsmodels. So I'm not going to put this on the Kaggle website because my score isn't high enough. I mean, if I'd had like an 80 or something like that, then I would put it on the Kaggle website and I would see if I could get my score improved. But since the score is only 75, I don't really see the point of copy and pasting every cell into Kaggle just to do that. And then so now what we're going to do is this is what we did the other day. We're going to visualize our PCA, that's principal component analysis, to make a 2D diagram, a two-dimensional diagram, which is what we've already done. So we're going to put X on a standard scalar and fit and transform it. And then we're going to get our mean and standard deviation. We're going to set up our feat columns. So those feature columns, which are actually the columns. We're going to make a normalized data frame, which is X, and then the columns equals feat columns. And then so what we do is we make a data frame with we set our principal components to end components because it's going to be two-dimensional. And then we're going to make a data frame with our principal components 1 and principal components 2, because that's what we want. We want a 2D diagram. And then so we put in the code for this 2D diagram, and you see right here we have a 2D diagram. So 0 means they perish, so that's red, and 1 means they survive, so that's green. So that's your 2D diagram. And then I decided that I wanted to make a 3D diagram as well. And so what I did was I put in the code, and then I got the code for both of these diagrams from Scikit-learn, but I did have to modify the code for what I wanted to do because the code was actually based upon the iris dataset, and I didn't want to do the iris dataset. So the code was actually modified, but I did get it from Scikit-learn. So we've got the code for our 3D, and I had to, make my labels as perished and survived. And here's our 3D diagram. And then you have something called PCA and logistic regression. And that's just something I was playing around with today. And I didn't do a very good job. I followed the instructions. This is the diagram that I got. So it didn't actually work that well. It just said that the best in PCA to use with end components was going to be 3. And it gave you a 72% accuracy. But I personally don't think it turned out that good. But this must be number 1, this must be number 2, and this must be number 3. And so it's saying number 3 is the best because this particular diagram, what they're doing is they're using a CV, cross-validation, to find out what is going to be the best PCA in components and what is going to be the best logistic C. And so logistic C was going to be 10 as well, but I wasn't really happy with that. But that's just what I was doing today. I wanted to make a video on that for you, so you can compare logistic regression and sklearn against logistic regression and Statsmodels. And logistic regression and Statsmodels, it gives you like a 3 percentage points better than it does in logistic regression sklearn. So that's something to take into consideration. So if you're going to be using logistic regression, then maybe it's a good idea to use logistics regression and Statsmodels, I would think. I'm definitely going to explore the functions in Statsmodels more than I have done in the past. So that concludes this video. I'm sorry that my speech stopped a little bit, but obviously I'm talking about a lot of really technical subjects, and sometimes I have to kind of like grasp to find the right words, and because I'm grasping to find the right words, it takes me a little bit longer to speak than if I'm talking about something like that's day to day. So please accept my apologies that my speech isn't that good, but hopefully as I learn more data science and I become more verbose at it, then my speaking will also improve. But it's difficult for me to speak about a subject that I'm still learning myself and is quite so complex. So if you like my video, please like, subscribe, and share. If you like the work I do and you want to make a donation, then I've got my email address to my PayPal account in the description box down below. And thank you so much for watching this video, and I look forward to making more videos for you.